So at the end of the last video, we were about to start number 7, which says a teacher carries his briefcase 20 meters down a hall to the staff room. The teacher's hand exerts a 30 Newton force upward as he moves down the hall at a constant velocity. Calculate the work done by the teacher. Okay, so here's the briefcase. He's putting a force upward of 30 newtons. And the briefcase is moving this way a distance of 20 meters. And it wants to know the work done. So W equals F delta D cos theta. W equals 30 newtons times 20 meters. But what's the angle? Take a look at the picture. What's the angle between the F and the delta D? It's 90 degrees. And cos of 90 is 0. The work done is 0 joules because of the direction of the force compared to the delta D. Number 8. Oh, and it says explain the results obtained, and it's because the force and the delta D are perpendicular. They're not acting in the same direction. Number 8. A 200 Newton force, so F is 200 newtons, acts horizontally on a bowling ball over a displacement of 1.5 meters. Delta D is 1.5 meters. Calculate the work done on the bowling ball. They should have probably started with this one because you don't need to rearrange it. They're both going in the same direction. So it's just 200 newtons times 1.5 meters times the cos of 0. And you should get 300 joules. Done. Number 9. The Voyager space probe has left our solar system and is traveling through deep space, which can be considered to be void of all matter. Assume the gravitational effects may be considered negligible when the Voyager is far from our solar system. How much work is done on the probe if it covers 1 times 10 to the 5th kilometers, traveling 3 times 10 to the 4th meters per second? Really, all of that is mumbo-jumbo except for one thing, which says assume the gravitational effects are negligible. In other words, F is 0. Okay, the space probe is traveling outward. It's just an object in motion that's staying in motion because there is no force acting on it. And if F is 0, then the work done is 0. Okay? And it says explain, we just did. Number 10 might be my favorite question of all time. An energetic group of students attempts to remove an old tree stump for use as firewood during a party. The students apply an average upward force of 650 newtons. The 865 kilogram stump. Do you have any idea how big an 865 kilogram stump would be? That is 1,903 pounds. Like, what kind of fire are they going to make? So the students apply an upward force of 650 newtons. Oh, look at this humongous tree stump. Let's do a bonfire. Okay, so the 865 kilogram tree stump doesn't move after 15 minutes of continuous effort. Really? It took them 15 minutes to figure out they weren't going to be able to move this 1,903 pound tree stump? And the group gives up. Oh, let's just gather some broken twigs around the floor instead. That should be enough. How much work did the students do on the tree stump? Well, the moral of the story, other than these students obviously did not take physics, after 15 minutes of continuous effort, the tree stump did not move. Delta D is 0, and therefore the work done is 0 joules, no matter how much force they put on it. All right, so that's the homework or the practice questions from the last day.